Good morning, everyone, and welcome to Mechatronics Projects Software Edition. Today I have a brief video of my machine learning indexer that I'd like to share with you guys. People are spending and volunteering millions of hours to index old census records for historical purposes such as family history, digitizing historical records, and many other reasons. The goal of this project is to build an AI to help streamline this effort and save many hours of work, especially considering that the census didn't go digital until 2020. For this project, I focused mostly on the 1940 census, as it is the one most recently released. Naturally, I took the classic programmer's approach to break this project into smaller problems. To do this, I will need to separate each of these rows and columns into individual cells, and then use the cells within a column to train the convolutional neural net to identify that data. So, in the interest of time and resources, I will focus on one column. To accomplish the first of these smaller problems, I need to get this table into a form that I can use. To do this, I convert the image to binary. Once I have this binary file, I use horizontal and vertical erosion filters to help find the grid lines. Unfortunately, this does not clean out all of the noise, so then I generate a histogram for both the horizontal and vertical lines. And that consistently produces nice clean grid lines for both the horizontal and vertical. Then, combining these two together, I can impose them on the original census image, and you can see here that I get a reasonably accurate table from which to pull my images from. The next problem to tackle was filtering out all the cells from the table that I didn't want and clipping the images off the census for identification. To do this, I start by collecting the centroids of all of the contours in the image. Then, using the top left corner of the table as a reference point, I specify a vertical and horizontal range to filter my contours down to the desired column. Once I have obtained all the desired contours, I can use a bounding box function to get a nice clean rectangular box, which I then use to clip the corresponding cells from the original census image. This gives me a bounty of images that can be saved and sorted for training or testing or fed to the neural network for identification. Before the neural net runs an image through its network for identification, the image must first be processed to ensure consistency. To do this, the image is resized, cropped, and normalized. Next is building the actual neural network, and in this case I'm using an adaptable convolutional neural net via PyTorch. This network is trained and tested using the sorted images from several census records. Here you can see I've plotted the loss of my neural network training, and once the training is completed, I give the neural network a fresh census that has never seen nor been tested on, and ask it to highlight, in this case, all of the females in the male-female column. As you can see here, this neural net did a pretty good job at identifying all of the females, misidentified one of the males there as a female, and then got all of the others. So we're doing pretty good there. So this trained network can then be saved to use and identify the images from this column on any 1940 census record. I also had this bit of code give me an output of the image with the prediction posted above it. So I could observe how the network was responding to a variety of different situations. For example, here we can observe that this particular training of the net failed when one gender was crossed out and replaced with another. Information such as this will help me fine-tune the network for more special case scenarios. Well, that about sums it up, so if you have any questions, please let me know. So until next time on Mechatronics Projects.